Hello and welcome. Today I'll be going over how to use PowerStage Designer in order to design the compensation components for the TPS-7H4001-SP. So once you get to this point in PowerStage Designer, which the previous video got us to, you can go up and click the loop calculator. What'll come up is this screen right here. And we're able to use this screen in order to find what components we need for the TPS-7H4001-SP. The control scheme is already correct for us here, which is kern mode control using a buck. But down here we need to fix the compensation network to type 2 transconductance. So moving over here, the VIN and the output voltage and the output current all got moved over from the previous design. So I do have to fix my output capacitance, so here I'll put around 2 millifarads as what I've chosen, and 1 milliohm of ESR. Cout 2 is used if you have, multiple capacitors in parallel, or you want to split up your ceramic and bulk capacitance values. But here, my total, I've put my total capacitance here of 2 millifarads and my total ESR of 1 milliohm. My switching frequency is already put in, and then for desired crossover, you should always be looking at, quite a bit lower than the double pull that happens to your frequency response at half the switching frequency. So you want to be a decade lower than that. But sometimes you want to be even a bit lower just to make sure you have a working product just to test out initially. And so I'm going to put about 30 kilohertz here as the starting value. Well, the GM that needs to be here is the GMEA of the device, so 1800 microsiemens. RS and AS, when multiplied together, equals 1 over the GMPS of the device. So the GMPS of the device is 40. So when I multiply these together, these should be about 25 milli. So, I'll put 25 here, and I'll put 1 here. Continuing on, the gain width band product and the AOL isn't always all that necessary. It really just determines, is this desired crossover frequency, extremely high for you? Down here, we can actually put the slope compensation. What I recommend is just to change this to SLM, which is the ratio of, perfect slope compensation. So 1 here will give you the perfect slope compensation you need for the design. I can put in my component values. So I have a 10 kiloohm right here. And for a 1, I'll put about 15 kiloohms. And from there, it'll give me suggested compensation values down here. Now it will determine everything based on the compensation values up here, and then try to give me an expected crossover frequency and phase margin. So if I put in those values there, I can see that I'm trying to hit around that 30 kilohertz crossover with as much phase margin as possible. It'll also give me the locations of my poles and zeros, as well as you have options that not looking just at the total gain in phase, but I might want to look at the phase of the power stage as well. Note that this graph here does not take into account any real-world effects such as delays, so these values are extraordinarily optimistic and should not be seen as something that you can expect to see from the true converter. Anyone wondering for what the definitions of the compensation values are in PowerStage Designer versus how they are defined in the TPS-7H4001-SP datasheet can look here, where RComp will be R1 in the datasheet, CComp will be C1 in the datasheet, and CHF will be C2 in the datasheet.